Everyone. Myself, Dr. Chandrabhushan Pal, FDP Coordinator and Associate Professor in Chemical Engineering Department, SN Patel Institute of Technology and Research Center, Umrah, Badoli, Babel, Surat. It is my privilege to introduce our esteemed speaker, Dr. Amit Arora sir, who has graciously accepted our invitation to be with us today. Dr. Amit Arora sir holds PhD from University of Illinois, USA, and MTech from IIT Kharagpur. With a distinguished career in education, he has served in various capacities at CTARA, Indian Institute of Technology, Bombay, first as an assistant professor 2010 to 2017, then as an associate professor 2017 to 2022, and since April 2022 as a professor. Dr. Amit Arora sir research is widely recognized with over 50 plus published research articles in international journals. He has actively contributed to the academic community, presenting his work at more than 35 international journals, 35 international conferences. His research expertise span bioenergy, bioprocessing, downstream processing, food processing, membrane separation, process design and development, microwave technology, paper and pulp engineering. Let's give a warm welcome to Dr. Amit Arora sir and hand over this session to him. Sir,
Thank you, Dr. Paul, for nice introduction. I hope you are able to, everybody is able to see the slides.
yes sir. Yes.
Okay, and you are also able to see the change in slide.
Yes.
Okay, all right. So good afternoon again, and thanks for this opportunity, Dr. Paul, to bring me here to the forum where I can interact with our young faculty members who are going to, uh, make significant changes and significant research in future. I think that is what we all expect from our young generation. So before we begin, I'll just quickly mention who am I. Already you have heard my introduction, but I'll just quickly mention that who am I, what I have been doing, and why I am doing. I think that part is more important than anything else. So as it was mentioned, so I started my research back in 2005 for my PhD program in the US. So during 2005, this was a sort of buzzword that everybody wanted to work in the area of biofuels and biorefinery. So I also was a part of it. So I joined University of Illinois after finishing my master's from IIT Kharagpur and worked there for almost 3.5 years for my PhD. Got my PhD in the area of corn-based biofuel production. You can see here the slides. So this is essentially corn or maize-based biofuel production, and you get several products out of the right-hand side. After that, I took up a postdoc position at same place for a year, and then almost for 6 months at Wisconsin Institute for Sustainable Technologies in Wisconsin, US. And I started working on second generation biofuels. I think these terms, biofuels, have become very popular now in Indian context as well, and we will discuss that as well. After I finished that, I got an opportunity to work in University of Wisconsin as assistant professor. So I spent about 2.5 years there at University of Wisconsin as assistant professor. So before I decided to come back to India in 2013 January. When I came here, I think this part is really, really important. When I came here, it was, of course, you can understand, and I basically changed my territory coming from US, now in India, and I am still finding feet to do some useful research in India. What we do in the US is very different. What is needed in India is going to be very different. I think that's very clear because our needs are different, right? So when I came here, all that work that I did there, that was not really fitting very well in our context. We were not producing good amount of biofuels. There was not much research happening in India at that time. I'm talking about 2013, the initial phase. And question is, considering the challenges associated with biofuels, India may not, at least at that point, might not be completely ready for take up that kind of research. So then I decided to do something which is more society driven, which is more applied, and which is more tangible.
in terms of generating value that can be helpful for our society. And that prompted me to join a specific center in IIT. It's called Sitara, Center for Technology Alternatives for Rural Areas, where our mandate given in the center is you do whatever kind of technology you want to do, whether it is very high-end technology or whatever. Your goal is very fixed. Your goal is to cater to the needs of the society. I think that's the focus, okay? Without compromising on the principles of engineering and science. We do high tech, cutting edge research, but your bottom line is those stakeholders who need that help. Solution can be simple and it could be sophisticated, doesn't matter, but it has to help marginal societies like farmers and so on. So that time I decided that I should focus on not just biofuels in general, but other things also, which I will give you a flavor of today. Okay. So what I work on is I essentially look at three major things here at IIT Bombay. One is, of course, my training is in biofuels and biorefinery. So I teach a course on technology aspects. I also cover the policy aspects of it. And I have PhD students who work in this area full time. Then another area which is very close to my heart, and I'll go to explain that today in this presentation about food and bioprocess engineering, where I talk about waste to wealth concept and waste to health concept. I'm sure you all are faculty members, so you are aware, you must be aware of these things. Is my slide changing or you are still stuck at the previous slide? Hello?
Yes,
I'm
it's changing.
just changing. I'm
sir.
just checking. Yeah, okay, all right. Because there is sometimes in Microsoft Teams there is a delay, so I was just checking with that. I'm used to using Zoom, so okay. If it is doing well, that's good. Okay, so I work in this area, and interestingly, I also look at health and nutrition aspect from two angles. One is I look at it from the point of view of data analytics. How do you understand health through data, where you would use, high statistical models and machine learning and so on, and nutrition also with that, with that lens. Plus, we also do lab work here to develop formulations that can address certain lifestyle diseases. So one of the work that we are doing currently is looking at diabetes as one, and second is cancer. So metabolic disorders. So how do you address those metabolic disorders using this route of nutrition? So that's another interesting thing that we do. Last part or last leg of my research or third leg of my research is on post-harvest technologies for sustainable value chain. And as you understand that India is primarily agriculture-based country, there are major issues involved in the value chain, especially when it comes to post-harvest part. So I look at that part as well. And in this presentation, you will be able to appreciate how these things are tied together. Okay. And if you wish, you can note down your questions. Feel free to ask me in between. Also, that is fine. I am open to that. Okay. So yeah. So waste to wealth was not enough for me. So I wanted to understand that, if we can address issue of health, then health itself as well. So that's my focus was. Okay. So let me really begin, with this slide, which is on one side, you see that how we talk about India as fastest growing economy of the world. And on the other side, we are dealing with with problems like increasing population, changing cropping patterns. Now farmers have small land holding and nobody wants to work in farmlands anymore. Everybody wants to move to urban cities, urban areas, and enjoy monthly salary. These things are happening. And climate change is showing its own implications on our planet, right? So you see there are two pictures. On one side, we are doing really well in terms of developing technologies. We are the most, I would say, young population in the world. On the other side, if you look at our flip side, is food loss in India is very, very significant. It's almost like $13 billion of worth of food that we are wasting every year in India, which is something we should not be proud of. India's rank in global hunger index is very low, 101 out of 119 countries. Again, we should not be proud of this fact. So even though we are able to manage things well in terms of production, we are not able to manage things very well when it comes to the supply chain part. So there are struggles, and struggles is on both count. How do you protect this produce that we get, and how do you pass on to people of our countrymen who are going to use this for securing their health. We should not keep our eyes away from the fact that even we waste 1 kg of material, if you translate that into energy and water footprint, that's huge, right? So as we move towards, say, 2030 or 2050 picture, today we are surplus in grains, but in 2050 we will be deficit in grains because the population is ever increasing and productivity of these crops is not going to increase proportionately, right? So these are the challenges that we have to face. So I diverted my attention to a very specific area. So remember what I said? I said I was working in the US in biofuels area. Their challenges were different. When I came to India, I found different challenges. And one of the major challenges in biofuels in India is supply chain. If you want to make a good, solid business of biofuels and biorefinery in India, supply chain has to be addressed. So I thought, as a new, young researcher, that let me do something in India which is more amenable and contextual. So I thought it might be a good idea to look at Indian horticulture space. Now, Indian horticulture space essentially talks about how much fruits and vegetables do we produce in India. Okay, so we have about, say, 300 million tons of fruits and vegetables that we produce every year in India. And if you just look at only 5% of that is getting processed. Okay, only 5% of that gets processed, which means we still have a huge scope for processing in India. And with this government's initiative, there is a clear push that in few years, we will be able to reach up to 20 to 25% of processing. In the pursuit of doing this, you will realize that we end up generating about 7 to 8 million tons of waste from processing. And there is also a significant amount of waste that comes from post-harvest losses, about 30 million tons. Okay, these numbers may not sound very high, but when you convert this into kgs, you will realize what we are discussing. So 30 million tons, meaning 30 multiplied by 10 to the power 9 kg. So that's your 30 billion kg of material that we are wasting every year. Now, the major challenge, if you look at, is how do you dispose this waste? That's a big problem, right? You all are biotech engineers and chemical engineers, you have pharmacy background and so on. So you can appreciate this problem that these are all organic matter with high biological oxygen demand. So they must be addressed very quickly. So how do you do that? That's a big problem. The current state of managing this is, sorry, a little cough the last couple of days. So how do you manage this? We end up dumping all this organic matter into dumping yards. We do not have the concept of so-called landfills. Landfills are popular in developed countries where you have a space and you can bury all your waste into the soil. Just bury inside and then get rid of that. We don't have concept of that. We have dumping yards where you must have seen mountains and mountains of organic matter just being piled up. Everybody just throws away municipal solid waste and then that basically converts into a huge pile of junk. Okay, so that's the situation in India. In terms of value addition, what we end up doing is producing biogas. You all know biomethanation process, so you can do biogas generation. Further value addition, if you are thinking of, you can do composting, or partly this particular material can go for animal feed. So I'll give you a simple example. Suppose a company is producing processing mangoes, right? We love drinking these mango beverages like fruity, you have slice, and there are different other products that you can buy from the market, fruit juices. When you produce this, you end up losing a lot of waste like skin and peel and so on. And this is a problem for the industry. Now, if you really look at from the angle of a chemist or a biochemist or an engineer, if you zoom into that so-called waste, what you see actually is a mine, it is a nutraceutical gold mine in this so-called waste. Okay, all good proteins, polyphenols, starch, everything that you could think of that can generate value, that can give value to human beings is already right there embedded in these so-called waste, which has potential to address these lifestyle diseases. And now that we all are consuming WhatsApp university message, every other day you will find somebody telling you, do eat this, eat that, and so on. You will actually find that all those good, polyphenols or antioxidants and good protein that we discuss and omega-3 and so on are already concentrated in this so-called waste. Okay, and I'll walk you through what we have done in this area for last 1 decade at IIT Bombay, and how you can take this approach further, in your institute and other places. Just to be able to appreciate this fact that data that health is an issue in India, the big time, we looked at diabetes data. You look at this diabetes data. This is coming from National Family Health Survey 4. Now we have NFHS 5 data as well available, but in this particular presentation, I'm not showing it. So clearly, diabetes was considered a rich man's problem a few years ago, right? But look at this data set that clearly shows you that this has also become a rural problem now. It is no longer a rich man's problem because it is directly connected to lifestyle. If our lifestyle is compromised, the way we eat, the food we eat and how we eat, it all translates to this lifestyle diseases like diabetes or hypertension. Okay, here is the prevalence of diabetes in India. You will see that how this is all pervasive. It's everywhere. And this is state-wise data. We can find where we are in Gujarat and Maharashtra. You can also look at other places, like Kerala, which is considered the highly literate state. Highest literacy you will find in Kerala. At the same time, per capita income is also very high in that space. But when you look at diabetes data, it tells a totally different story. So why this is happening, what is happening is because of this change that has happened over the decades. We have moved away from traditional foods to convenience foods. So instead of consuming more complex carbohydrates, proteins, fats, fibers, micronutrients, we are now resorting to eating more refined carbohydrates rich diet, and any kind of fat is okay as long as it is tasty. And we do not realize that we have ended up eating more sugar, and that too more of a high fructose sugar. Okay, and feel free to ask questions if you have any in the middle of the presentation. If you don't understand any term, I'll be happy to explain. Okay, so all that put together, say calorie overdose, deficiency in protein, the kind of protein, which amino acid profile, and so on, and micronutrient deficiencies, all these lead to these problems of metabolic disorders. It's not just diabetes. In fact, new research says even cancer is an outcome of this metabolic disorder, which is directly related to how we live our life. It is not just, people have different misconceptions about cancer. It is actually directly connected to the food component that we consume on daily basis. So what we have done, we actually looked at this horticulture, or I would say food processing companies, in a very detailed manner, and try and understand in Indian context, can we generate some value out of it? Now, part of the reason why I'm choosing these Indian food industry is because they do not generate any value from this waste. That is one. Second, the major issue with supply chain of biofuels that we have seen in agricultural residues. For example, you talk about Delhi Parali issue, and I'm sure you all know about this fact. There also the major problem is these farmers, they burn their stubble, the crop stubble, because they don't know how to manage the supply chain. They know that this is burning of this, farmland, the crop will have some implications, but there is no choice for them, right? So they end up burning because there are certain ephemeral benefits that they get right there, okay? But in long run, there is a loss, which I think we all are observing with this climate change. So I decided that these food processing companies, they will generate waste every time when they process something, which means these are point sources. So I don't have to go door to door and collect this waste. These are point sources where I can easily collect this waste. okay, and then do something useful out of it using our training and engineering. So here what we have done, we have developed fruit processing waste biorefinery coming from mango, pomegranate, pineapple, to name a few. There are many other things that we have done. We also looked at plant-based proteins. Nowadays, everybody talks about proteins and plant-based proteins and meat analogs and so on. So we have looked at those aspects as well. And of course, as I said, now India, our existing, the current government is pushing very hard on biofuels. So I'm also looking at agricultural residue-based biorefinery, how it is possible and how it can be done uh, in a more just manner, which can give you a viable opportunity for a biorefinery concept. What is biorefinery? I'll explain. Okay, so here what you see, this particular slide, it says we are going to manage this fruit waste. That is one of the major problems that industry faces for a sustainable future. So if you look at on the left hand side, this part, we have India is known for this fruitful bounty. We are either number one or number two or number three across the globe in terms of production of these fruits. Okay, which is a very good thing. But as I said, we end up wasting a lot of them during post-harvest losses, and also during processing, all the skin waste and everything and the spoiled fruits, they end up going to dumping yards. So by taking this approach, we can actually address certain SDGs, which are called, I hope you are aware of SDG, Sustainable Development Goals. So here we can target the Sustainable Development Goals and address those issues like responsible consumption and production, climate action, and so on. So idea here is to extract those high value components, optimize their recovery, purify them, and be able to keep it ready for market. That's the idea. Okay, so this you could do, that is possible, and with our training we can do that. But the most important thing here is, when we have to do this, keep one thing in mind, that we should not compromise with certain facts. For example, if we want to do something like this, we should minimize water footprint, we should minimize energy footprint, we should minimize the cost, we should not use non-renewables, or we can use non-renewables but to a limited extent, and sustainability should always be in the center. So whether it is economic sustainability, whether it is social sustainability or economic or environmental sustainability, that should be the focus. Okay, so that is more important than anything else. And that's where our role is, how do you use green chemistry pathways to address these major issues. Okay, that's our USP. So now comes biorefinery. What is biorefinery? I'm sure you are chemical engineers, so you understand this. Those who are not aware, some biotech people also understand it very well. Those I am not aware of, who else is the participant here. Those who are not aware of this term, I'll explain this very quickly. Basically, this is a black box. You take raw material in and it's going to give you several products. Okay, biorefinery word is similar to petroleum refinery. What happened in petroleum refinery? You take crude oil. Okay, you take crude oil, which is one single stream feed, and you convert that into several products, right? You do fractional distillation, you get petrol, you get gasoline, gasoline, petrol are same. You get gasoline, you get diesel, then you get waxes, you get differential kerosene, and so on. Likewise, you can produce many products out of one crude oil. Similarly, you can take different types of biomass feedstock, and all that can be converted in this black box into your desirable product. And here I am giving you some examples. One can produce bioethanol, biodiesel, hydrogen, electricity. Some nutrient recoveries are possible. Now everybody talks about bioplastics. You can do that as well. You can produce high value biochemicals and so on. Okay, so all that is possible with this approach. Now let me walk you through a good example of mango waste. So this is the first work that we did in IIT Bombay. That was almost like 12 years ago now. When we started this work, it was 2013 or 2014 maybe. Okay, so look at this processing waste that is in a company. I'm sure you have heard about, say, Sayatri Farms, or you have heard about Mapro Industry or Jan Farm Food Park and so on, or ITC, Nestle. What they do, they have this mango processing line, and they take out the mango pulp part. Now remaining part is mango peel and mango seed. Okay. Now this mango peel and mango seed, basically these are rich in certain components. Here you will see pectin. It's a polysaccharide. It's very rich in, this is a dietary fiber which has its own value, and total polyphenol. Polyphenols are antioxidants. These are very useful. On the right hand side, you see mango seed. Okay. बचपन में आप सबने try किया होगा mango seed. You must have opened it at least once in your childhood. And what you will find when you open the hard seed coat, there is a small soft mango kernel inside, right? Now this soft mango kernel is actually very rich in starch and oil. So all these starch, oil, fiber, protein can be fractionated very well, and you can have multiple products coming out from the so-called waste. So that was the idea. Okay, so all these components that you see, we separated them. So that was the research that went into optimizing all that. So it is not that pectin is not available in India and other places. Yes, it is there. But look at the production of that. The slide that you see today, it talks about commercial pectin production happens. Large part of pectin is produced in China, okay, not in India. And second, I think comes Germany, European countries, but Germany and Switzerland, these two places also produce a lot of pectin. And there are few in US as well. In India, it's mostly, I would say, repackaging than production. It's limited production. It's there, but very little. Mostly it is repackaging of pectin that happens. You might have heard about Krishna Pectin Company and so on. There are many other companies as well. Okay. So what happens here is, so here you look at raw material comes to the factory. They acidify this, the waste. I'm talking about, say, you take example of citrus waste, because citrus is used for this purpose. So you have orange peel, you dry it, powder it, mix with acid and water. Here and then heat it up at, say, 90 degrees Celsius for, say, 3 hours, and this will essentially dissolve all that pectin into protopectin. Now pectin is dissolved. You are going to separate it out here by precipitation method. How do we do precipitation? We add either ethanol or isopropyl alcohol. Okay. So by adding this, you are precipitating pectin, and this pectin polysaccharide, finally we separate out, dry it, mill it, make a powder form, and then pack it. So this is how we produce pectin. Those who are not aware of this pectin, what this pectin is and where do we use it, I said this is a dietary fiber, but major use of pectin is in making jams and jellies. All that Kisan jam and then other jams that we eat, it has pectin, and pectin comes from this process. Okay. Is it making sense? Are you able to hear me well? Just nod so that I'll know that I am audible and everything is going okay. Yes, no?
Yes. Sir.
Okay.
All
If
good.
I'm going too fast, let me know. I can slow down, or if it is okay, then I'll continue.
Yeah, sure. It's perfectly okay, sir. Everything is fine.
Okay, good. Thank you. So now one thing you will realize, there are two steps. I have just shown this with these dashed lines. We are using mineral acids on one side. On other side, we are using isopropyl alcohol or ethanol. And if you know, and I'm sure we are chemical engineers and biotech and so on, wherever you use ethanol, there is a significant amount of energy that will go into the unit operation, because you also have to recover this ethanol in the process, right? So that's an energy intensive process. And if you are using mineral acids have its own consequences. So our research was, can we remove this acid? Can we develop a process where we do not need this acid? Can we develop a process where we can get away from using ethanol in this form, or can we reduce the amount of ethanol that we need in order to make this pectin production process more viable? So with these objectives, we developed new processes, we took patents and so on, but we also looked at impact of the process on climate change. So here you will see, this is just a sample, the model number that you see here. When we look at this current process, it's going to take about 9.35 kilogram of CO2 equivalent generation, versus the production that we developed, the process that we developed, is taking about, say, 2 kilograms. So you clearly see the difference between these two. So you can reduce 1/5 of total carbon dioxide production by generating 1 kg of pectin to the new process. Okay. So idea here is, how do we generate value from this waste, so-called waste, rather than sending it to the dumping yards where you will see one big problem of fire hazard, right? That's very known, very evident. If you have ever come to Mumbai or have gone to Delhi, there are two places you can go to. In Mumbai, there is a place called Deonar. You will find piles and piles. It's like a real mountain of waste. Okay, and you will see that such kind of fire hazard happens every now and then. We hear about this in news on daily basis. Why it happens? The major reason why it happens is these are organic matter, and these organic matters, if they are going to spoil in less oxygen, you know that it's going to generate methane, right? And methane is going to catch fire very quickly. And once this methane catches fire, then it just burns for days. So these are the problems that you see. Okay, so instead of doing that, you can actually come up with a totally new concept of generating wealth from this so-called waste. And what we can do is we can produce so many products. Pectin is one. You can produce ethanol from starch and sugar, or you can have starch for textile industry, paper industry, and so on. You can generate antioxidants, and you can generate oil. Now, this oil that I have mentioned, this oil is not a regular oil. This oil can replace something which you might like a lot is chocolate. So chocolate needs cocoa butter. Okay, cocoa butter is very expensive, but this oil can replace that cocoa butter, and you can use that. Okay, so now you're able to see how the value generation is possible from this waste. So our process now, if you want to compare, what we have done is, first of all, we have removed this mineral acids to green solvents. We are, instead of using IPA, we are using purely bioethanol. Instead of using ethanol in great quantity, we have shifted from regular evaporation process to membrane process, and so on, to be able to make a green biorefinery which will have very small carbon footprint. That's the idea. Okay, there is much more to it. If you are interested, please look at these papers that we published in 2018, Process Design and Techno-Economic Analysis, where you will find all the numbers, all calculations, whether this makes sense or not, is it economically viable, what is the scale, and all these questions can be answered if you look at these kind of papers. Okay. Second, I'll mention, I'm not going to get into details of it, but I'll just quickly mention the similar concept you can try at other fruits as well. For example, here it's called integrated biorefinery concept from pomegranate processing waste. Similar concept, similar thing we tried with this. We developed new processes for pectin production, and then not just pectin production, but we also looked at how we can produce more than pectin. Okay, so here you can see, we took this waste, 50-60% waste comes from the industry. We separate out peels and seeds, and we could able to generate value from this by extracting pectin, sugars. This seeds will have its oil and protein and so on. So in terms of process development, what we did, we actually tried two different methods. Okay, so first method, let me talk about this one first, hydrothermal process based biorefinery. You look at this part here, we get peel, the peel that is coming from industry, you actually process it through hydrothermal processing. What is hydrothermal process is, we are not using any acid or alkali, we are not using any chemical, but we are heating water. We are keep on heating water under certain temperature and pressure conditions, and you are still keeping it in a subcritical condition. We are not going supercritical. Okay. Under that condition, we are able to separate pectin and polyphenols. Once you have separated this, all that residue that is coming out, now these are all agriculture. Basically, these are more of a cellulose and hemicellulose and lignin. So you break them and you use enzymes to be converted into alcohol. So that's the idea. These enzymes will cut down this cellulose into simple sugars, and these sugars will be consumed by yeast to produce bioethanol. So that was the idea, and we have published our patent and so on. Second approach we took was that instead of going through hydrothermal process, we actually immobilize enzyme to separate this pectin and puricalogen. Puricalogen is a very potent phenol, highly valuable polyphenol, very expensive in market. So we tried separating them using enzymatic approach, and we were quite successful doing that. Okay, and it's an enzyme immobilization process. You can do with regular enzyme, but if we tried reutilizing the same enzyme by recycling it as many times as possible. So what we did, we basically immobilized it, and I'm sure biotech people, they do it all the time with other things, but we wanted to see at the larger scale whether it is successful. So this is the process that you are aware of. Magnetic nanoparticles we developed, with AP test we combined, functionalized the unit, and then magnetic nanoparticles were coated on this AP test. Then you can clearly see that how they are now, they develop here bonding with cellulase enzyme with the help of cross-linker called glutaraldehyde. And you can see here at the right hand side here that cellulase magnetic nanobiocatalysis is ready for its function. And it's also very easy because now they are connected with magnetic nanoparticles. We can easily separate out using magnets. Okay, so that's the new biorefinery concept that we used. So you started off with pomegranate peel powder. Here we have used cellulase magnetic nanobiocatalyst, or you can just call it magnetic nanoparticles loaded with enzymes. We do the process, and here once this enzymatic hydrolysis is done, this is how we separated these nanoparticles with magnet. And once you separate it out, this is ready for recycling. That's the best part. Okay, then you continue to do this, separate each component, and then you get pectin and concentrated polyphenols. So all this work was done a few years ago. And if you look at yields were very good. Conventional process pectin, you see yield is about 19-20%. Similar yield we got in magnetic process, and polyphenol yield is also very good compared to conventional process. And this is how we separate these nanoparticles, basically enzyme loaded nanoparticles using magnet. And once this is separated, then you can recycle. So we actually tried this recycling of this whole thing at little larger scale. And you can see on right hand side, there is a curve. It's a yield curve. And here is number of recycle. So we did not see loss of enzymatic activity at least for 5 recycles, and which is a good news. And after that, of course, as you go further beyond 5 recycle, you will see that enzyme activity goes down, but not goes down very significantly. Say you will see 20-30% loss. That 20-30% loss, you can make it up by adding fresh enzyme. That's absolutely possible. But we did not do it. We stopped after 5-6 recycle. We noticed that after 5-6 recycle, there is a drop, and that's where we stopped. Okay, but this can also be managed, which we did it in another experiment, not with pomegranate, but with something else. This I already explained to you how it works, so I'll pass this. And this is the comparison that you can see in what happens in magnetic nanobiocatalyst approach versus hydrothermal approach. In both cases, if you look at the yields are pretty much same. Statistically speaking, they are same. The quality of pectin is always decided by this term called galactouronic acid content. That's the backbone of this pectin polymer. Okay, to each other. DE is called degree of acidification. That's also very good. Higher the number, higher the degree of acidification, which has very specific uses for making jams and jellies. Okay, so that's where it fits very well. And this is a molecular weight range. So this is for pectin. Now same thing we did for phenolics as well, and you will see that not much difference is there in both cases. So the point I am driving here is whether we use enzymatic process or we use non-enzymatic process, both are going to give you good yields depending on the conditions. Suppose I want any farmer group to work on this, I would suggest go with hydrothermal and not with enzymes, because sometimes enzymatic process is a little sophisticated. They will have their own issues with that. Instead of that, you give something which is more sturdy, which they can control easily, something like start-stop button that might work well for them. And that's where hydrothermal treatment is much better compared to enzymatic process. So similar picture you will see here, how we have generated a biorefinery coming from pomegranate, 1 ton of waste. By the way, this is not dry waste, this is waste as is coming from industry, and you can generate this value. The numbers that you see here, these are real numbers. This is international price, $11 to $13 of pectin per kg. If you want low quality pectin, probably you will get at $7 from China. In India, we buy at $7 from China in a big way, $7 to $8. But good quality pectin, if you want to make good products, then you have to pay roughly about $11 to $13 for a kg. Okay, so that's the business. Likewise, we did this work with pineapple waste as well. Okay, and this story continues, but I'll quickly mention. So this work was done in Darjeeling. Our students, they went there. You can see here in this picture, my student Shivali and Mayur, and this is me. So we are actually visiting this plant, this farm in Darjeeling. In West Bengal, Darjeeling is known for maximum production and good quality pineapple production in India. So that is number one, and then comes Karnataka and other places where you get a lot of pineapples. So we worked on both sides, on-farm waste and processing waste. We processed both, and we generated a lot of value from that as well. So here you will see, here is a biorefinery concept. We took pineapple processing waste and we converted into many products. You can see here there are many products so I'm sure some of you might know this already. Pineapples have inherent enzyme present in it. This is called bromelain. Like papaya has an inherent enzyme that's called papain. And this enzyme, bromelain, has shown very significant activity during COVID period. And I'll mention that. And that's where this concept came to us, that why don't we extract and purify this enzyme coming from waste? So we did that. And we got dietary fiber recovery. We also got, I'll talk about this. And we also got biofuels and biochemicals production. Now, one very interesting thing that we did was, in the process of extracting many things, one thing that we extracted is called xylo-oligosaccharide, XOS. It might be new to some of you. Basically, this is a prebiotic. Those who do not understand what is prebiotic is a food for beneficial bacteria of our body. And we all know that if we are keeping our gut health good, then our body will also perform really, really well. This is a new research in science that is happening, that we must keep our gut health very, very good. Then all rest of our body organs will also perform really well, including our brain activity. Okay. So this food, the prebiotic food, is a food for beneficial bacteria in our gut, which means it will help whole of our body when you consume this. Okay. You must have heard about Yakult. Yakult, आपका जो शिल्पा शेट्टी बेचती है, same, right? Advertise करती है, not बेचती है. So that is a probiotic. She advertises it for consuming probiotic, which is basically live bacteria. जैसे आप लोग दही खाते हो, या फिर आप छाछ पीते हो, right? These are live beneficial bacteria that we consume, lactic acid, bacillus, and so on, right? But here we are developing food for those bacteria, which will help them multiply well. That's the idea. So another project that we looked at is cellulose nanofibers from pineapple on-farm waste. And this is an era of nanobiotechnology. Everybody talks about nanotech and so on. And a lot of research has happened in this area. So I won't get into it. The point I'm driving here is how we are generating wealth from waste. Cellulose fiber, we break it down into a level where we can get these small nanofiber scales. And these nanofibers can find application in many areas. Okay, so we developed that part as well. Yeah, this is what I was talking about, development of novel prebiotics for gut health. Okay, so we developed XOS, xylo-oligosaccharide, pectin oligosaccharide or pectic oligosaccharide. All these new prebiotics we developed from this waste. It can help you from, protect us from many pathogenic bacteria and anti-cancers, cancerous conditions and so on. So these are the research that we have done. Those who are interested, you will find these papers published. So feel free to look at these papers. Yeah. So how do we generate this prebiotics? That's the next question. So prebiotics, our target was we will take agricultural residue and we will target cellulose for making ethanol, and we will also make cellulose nanofibers. So that is the use of cellulose. Another abundant raw material in this raw agricultural biomass is hemicellulose. Those who do not understand what is hemicellulose, it is basically hemicellulose is a polymer of 5 carbon and 6 carbon sugar. That's it. Okay, that's in simple words. So here I can show you this picture. Here you will see pentoses and hexoses. These are 6 carbon sugars and 5 carbon sugars. When they are in polymeric form, these are called hemicellulose. These are very amorphous in nature, very soft. You can easily remove it from complex cell wall. You can see here, that's easy to do. So we removed it, we extracted it from, say, this is your residue, agricultural residue. About 20 to 40% of hemicellulose is present. We separated it, purified it, and we got this prebiotic called xylo-oligosaccharide. Now, xylo-oligosaccharide is what exactly it is? It is essentially it's a sugar molecule. Okay, it's a sugar molecule, and sugar is xylose, not glucose. It's a xylose, XYLOSE, xylose. When they are connected together, either 2 molecules or 3 molecules or 4 molecules. Okay, disaccharide, trisaccharide, or tetrasaccharide. We do not go beyond that, because if you go beyond that in terms of their chain length, then it will lose its activity. So we develop processes, alkaline enzymatic process, auto hydrolysis enzymatic process, green processes, to be able to get this prebiotic. So that was the idea. And we did not stop it there. We also evaluated effect of these xylo-oligosaccharides on bacteria. So we did actually complete our study on fecal cells and so on, and we published this work as well. Okay, so you can refer to these papers whenever you wish. So it's easy to understand these prebiotics. When it gets fermented in gut, then the short chain fatty acids get generated. You will have acetate, propionate, butyrate, and so on. And each fatty acid that you see has its very specific activity in our body. Okay, and you will see that how it does that. For example, butyrate that it generates, it's an energy source for colonocytes, and that's very, very important for our body, for our body's defense and activity. Okay, so here are the steps. This is how we actually developed these products. Here we are taking example of almond shell, the hard almond shell, badam ka jo bahar ka cover hota hai. So you can convert that also. So anything, any biomass can be utilized for this purpose. All that you have to have is good amount of hemicellulose present in it. Okay, and then finally you will purify using membranes and so on, and then you will get the final product. Okay, this is essentially the same thing. It just tells you the how much, what is the product, what is the purity of this sample that we get, and so on. So we also did, there are many other projects that we have been involved in. For example, looking at extraction of natural colors, smart packaging material using pectin. We are also looking at onion waste to wealth concept. There is so much onion that is being wasted in India because of post-harvest losses. What can we do in order to generate value from that so-called waste? And our current research, one of my PhD students, she is looking at what are the other non-edible applications of plant proteins. We are already extracting plant proteins, we are purifying, we are making blends, all that we are doing, but we are also trying to see whether we can do something which is non-edible in nature. Maybe adhesives, maybe something specific work, maybe it can work as, especially certain peptides, that can also work as an insecticide. You can spray, you can use these kind of peptides as an insecticidal spray. So all those possibilities we are evaluating at this point. An example of pH sensitive and edible antimicrobial packaging film that we have developed. You can see our students have done this job. all this color that you see, these are all coming from these waste sources. So here there is a good example. You will see waste that comes from farms, right? So sorry, not waste, the produce that comes from farms, it goes to industry. There they process the fruit, and there you will see the concept of biorefinery. Here we are generating this pectin, and same pectin you can use in Kisan or Mapro industry for making jam and jelly, right? So it's a complete cycle. And the waste that it produces, same waste we are using for making coatings and wraps, which can increase the shelf life of your produce. We all know that agricultural produce does not have a longer shelf life because they have very high moisture content. So we can make these edible coatings or these bioplastic coatings, which can increase or enhance their shelf life. So we have done that part as well. I'm not including it here because it's very long presentation today. Okay, so overall goal, see, you can clearly see the idea is to minimize need for single-use plastic and reduce food waste, so that we can considerably lower the greenhouse gas emissions. That was the idea. So this is how we did this work, and we got very good results. In fact, this is something which I would like to talk about in a minute. This is very interesting work. So what we did, if you look at here, 1, 2, 3, 4, 5, 6. You will see there are 6 different types of packaging material that we tried. One coming from pectin and CMC, and here we are using PEG-DE. This is polyethylene glycol, dextrose, so on. Here, what we tried is we also use honey. You know that honey is a natural anti-microbial agent. So we tried Manuka honey. Manuka honey is considered as one of the best antimicrobial honey. So we use that. We also tried inorganic compound. We took bismuth salt. Bismuth salt is known for its own antimicrobial activity. We combined that effect. And what you notice here is that they have quite marked difference in optical density when you use combined effect of honey and bismuth. And this we tried with positive control. You use, antimicrobial agent, chemical, to see what kind of changes do you observe. So this was at par with any synthetic antimicrobial agent. So this is about biorefinery concept. Okay, I'll take 5 more minutes before I stop, and this is about our approach towards malnutrition in India. As I said initially, I also work in the area of food and nutrition. So when it comes to nutrition, we must acknowledge and appreciate the problems that we face in India. One of the major problems that we are facing in India is anemia, because there's a huge problem. Another problem is we are largely deficient in most of the micronutrients in India. Now, one of the major problems that why we have this problem in India of anemia is that we drink a lot of tea. Drinking tea is not that much of a problem if you are drinking it not combining with our food. If you eat food and after that you take tea, that's the worst combination when it comes to iron absorption. Okay, so here we understood the mechanics of these things, how it works, and how do we enhance bioavailability of iron that we consume in body, and so on. So we developed product with high bioavailable iron. अभी आप देखेंगे जब प्रेग्नेंट वुमेन होती हैं तो डॉक्टर्स क्या रिकमेंड करते हैं कि ये टेक दीज IFA टैबलेट्स. ओके, दीज आर IFA मीनिंग दिस इज आयरन एंड फोलिक एसिड टैबलेट्स. लेकिन वो प्रेग्नेंट वुमेन उसको कंटिन्यू नहीं ले पाती हैं. कंप्लायंस इज वेरी डिफिकल्ट because this gives them nauseatic feeling and nausea feeling and so on. Very, very difficult to consume it, right? And if you take very high concentration of these iron, what will happen is, if they are not absorbed really well, they also generate free radicals in body. Free radical generate many other biochemical reactions in body, which is not good for us. Okay, for example, quick aging of body happens. Free radicals tends to reduce the lifespan of cells and so on. So that's not a great idea. What we did, however, is, if you look at this process, our idea is to have food-based intervention where we are not using any chemical-based iron powder. We are taking food route and we are reducing the iron absorption inhibitors. We are enhancing the iron absorption enhancers in the food, and finally we developed a product which is a plant-based ready-to-eat bar and chips. So now, just like Lay's packet, just like 2Yum or any other product that you can buy from market, you can just open this packet, eat it, and it will give you 6 times more available iron than a regular meal. So this is the kind of work we have done. In this picture you are seeing on the right hand side, she is Miss Elizabeth Foray. She is director of World Food Program India, and she has visited us many times and appreciated the work that we have done. Now they are very much interested to take this work forward nationwide. So that's another approach we are looking at, how this product that we have developed can be utilized by Anganwadis and so on, so that everybody can get benefited. And why just Anganwadis? Even in urban sector, there is a misconception that urban sector people understand these things very well. This is not true at all. Look at anemia of women in India in urban area. Almost 47 to 50% of them are anemic today. Okay, so they are equally important for us to be able to give these kind of products to them. So we also address issues like micronutrient deficiency. We call them hidden hunger. So we develop products here as well, where we are able to give everything natural in one simple sprinkler powder. You take this sprinkler powder, it will be like Inu or Maggi masala packet. You open it and add in anything and consume it. This will give you one full RDA meal for micronutrients that you need on daily basis. The Shruti did this work, and the previous work that I mentioned on protein rich bar and iron protein rich bar, this was developed by the PhD student Ashi. We also came up with the concept of replacing eggs, because not everybody that eats egg, right? So we were talking with Akshay Patra, for example, and I'm also pure vegetarian. So I'm looking at opportunity. How do we replace egg and develop products that have equal nutrition, macro and micronutrient, compared to what we have in egg? So there's something that I developed. That's why I say student Amit. We did this work, and we are taking this forward with ICMR, Indian Council of Medical Research. And this was tweeted by Ms. Elizabeth Faur. You will find this news. It was quite in news for some time. This work that you see, protein deficiency, I think already talked about it. 70% of our population in India are protein deficient. Okay, and we are suffering from it, not because we don't have sources, just that we do not have access to that properly, and how much one should consume, that awareness is also very limited. And not that everybody is non-vegetarian. There are people who are vegetarian. Those who are non-vegetarian, their frequency of eating non-vegetarian food is also very limited. So how do you get good amount of protein? When I say good amount is not enough, qualitatively it should be good, which means essential amino acid profile should also be really, really good. So we took at all that into consideration. We realized that in time to come, देखिए हम जब भी sustainability की बात करते हैं आगे के लिए, we need to understand that we have limited water, we have limited energy, we have limited farms. How do we make use of that for our future generation? So look at this amount of water that we consume. 1 kg pork, 1 kg pulses. Compare these two, 1 kg beef or any other meat or mutton, whatever it is. There is no comparison, right? So in time to come, we have to have a more sustainable approach to be able to get equivalent amount of protein. And that's where my argument is, we can basically shift to vegetarian food to be able to do justice to sustainability. That's very important. We cannot replace what we get from non-veg food, but there will be a point in future where we have to depend on these vegetarian sources. Come may what, does not matter what happens. Okay, so that's the situation. So greenhouse gas emissions, one of the major issues, I think this is the right point to point out. If you have ever visited any poultry, I don't know how many of you have done it. If you get chance, please do so. Okay, you will realize that how these poultry are treated. Okay, these chickens and hens, how they are treated. And biotech people will appreciate this point that if you keep any animal under stress, they will release certain chemical compounds in their metabolites. Okay, these could be eggs. Eggs will have certain types of chemicals which is not good for your body. They are given antibiotics like anything because poultry is very sensitive to many diseases. When you give these kind of antibiotics, what will happen? Antibiotic resistance will develop with time. All that finally is going to end up in your food. Okay, so that's a big problem, and this is the research that we have looked at. These are published articles, newspaper articles, chemical used to freshen up rotten meat in West Bengal, prevalence and antimicrobial resistance of salmonella in egg storing trays, and so on. Silent killer of Indian farmers. You see the problem is very, very significant. And what it does is it just disturbs our body completely. It alters the microbiome in our body, the good bacteria part. It reduces our antioxidants in our body. Glutathione, the word that you see, that's a major potent antioxidant which is present in our body. So it directly compromises with that. And it increases inflammation in our body. Once you have higher inflammation in body, it will create multitude of problems in body. You see, one mistake done in poultry will lead to these big issues. And this essentially leads to metabolic disorders. So we tried and see what can we do in this space. So we took all that waste oil cake that can be used for making proteins. So we developed different types of proteins. We did simulation and modeling and so on. After lab scale, we went for pilot scale work. We developed different types of protein blends. So started with 10 grams and finally we reached to 1 kg material. And now we have a setup where we can do 5 kg as well. And eventually we were able to develop good protein blends, which has a good essential amino acid profile as well. Okay, now we are targeting, can we go for clinical trials? And I just mentioned briefly that ICMR body, Indian Council of Medical Research, they are very much interested in taking this work forward. So finger crossed, hopefully that should also happen. Okay. So one of the things that now we are looking at is whatever work we are doing, can it also address issues with cancer? So Tata Memorial Hospital in Mumbai, so we are collaborating and we are looking at how nutrition can help in beating the cancer part, both preventive and curative. So both sides we are trying to understand whether it has that potential. We are also looking at smart food formulations for anti-aging. Now anti-aging has become a buzzword in India. Everybody talks about it, at least in WhatsApp messages and all that, you will see that. So we are also looking at it, but purely from the science perspective, what can be done in order to improve our health status. Machine learning application in nutrition space, I think everybody talks about machine learning nowadays. So yeah, so this is all I had for you. Thank you very much. Thanks for your attention. And if you have any question, please let me know. Thank you. So these are the companies and groups and people I'm thankful. They supported our work through funding and others. Thank you very much.
Thank you very much, sir. Sir, one of the questions asked participant, can you please explain the difference between parabiotic and prebiotic?
Sorry, can you say again? I couldn't hear. Can you repeat the question, please?
Yes, sir. Can you please explain the difference between prebiotic and prebiotic? Same.
Oh, prebiotic and probiotic, I guess.
Okay. Yeah.
I think, yeah, it was written, probably spelling was wrong. So
Yeah.
so let me explain first what is probiotic. Probiotic जो होते हैं ना, प्रोबायोटिक बेसिकली लाइव बैक्टीरिया होते हैं. जैसे हम लोग को बोलते हैं डॉक्टर आप कर्ड खाइए, आप दही खाइए. दही में क्या होता है? इट हैज अ लैक्टोबैसिलस बैक्टीरिया, right? So these are good bacteria. These are called beneficial bacteria. These are called probiotics. Now when you consume it, it is going to keep your gut healthy and everything will be good. This is probiotic. लेकिन अगर आपको इस बैक्टीरिया को हेल्दी रखना है तो इसको भी कुछ फूड चाहिए होगा. वो जो फूड है, दैट इज कॉल्ड प्रीबायोटिक. एंड व्हाट दैट फूड इज, वो फूड हो सकता है जो उस बैक्टीरिया के लिए अच्छा रहे. व्हाट काइंड ऑफ फूड दैट कुड बी? I gave you example. जैसे मैंने pectin बोला, pectin XOS बोला, xylo-oligosaccharides. Now Tata Chemical Company has introduced this one new prebiotic called FOS, fructo-oligosaccharide. कभी भी आप कोई न्यूट्रिशन बार खाएंगे ना मार्केट से खरीद के, जैसे योगा बार वगैरह है, you will always find FOS written on that. That essentially is the prebiotic part. आपको नेचुरली भी ये मिलता है. यू कैन ऑल्सो गेट इट नेचुरली. जैसे आप अनियन खाते हैं, गार्लिक खाते हैं, उसमें भी होता है, वेरी लिटिल अमाउंट, बट इट इज देयर. इट इज कॉल्ड इनुलिन. Does that answer your question? So prebiotics is a food for probiotics, and probiotics are beneficial bacteria.
One more question. Lactobacillus. Someone asked the term lactobacillus.
I think somebody was helping me. So this is lactobacillus is the
Okay,
word I was suggesting. Yeah.
yeah.
That's a probiotic, yes.
Okay. Anybody ask any questions?
So question is cellulose nanofiber application. See, actually there are many. There are many applications. Starting from, I would say, starting from something very high. You look at today, in today's era, we are talking about shifting towards bioplastic and biocomposites, nanocomposites and so on. Right. So one of the major areas where we are looking at application of this is this this carrier flights. अगर जो हमारे हवाई जहाज होते हैं, how do you reduce the weight of that? That's where the internal compartment that you see when you get inside the aeroplane, you see all that fiber that they use, that can be replaced with this, where you can use nanocomposites using this cellulose nanofiber. It can provide same amount of tensile strength. It will have all those good physical properties without compromising with that. You can still reduce the weight by a significant amount. That is one application which you will find in air. Now, something very basic, you can look at how people are utilizing this for making sanitary pads. One of the major issues with sanitary pads that you buy from a market today, these are all non-biodegradable, first of all. Right? You will have plastic coatings and all. If you open it, you will see there are layers and layers of that, which cannot be degraded. और कितना बड़े क्वांटम में इंडिया में आपको एड्रेस करना पड़ेगा. Just imagine how many girls are there, how many ladies are there. They have to dispose that. It's not easy. It's very difficult. But if you can use these nanocomposites, they increase the absorption capacity of these fluids very quickly, very strongly. Okay, so this can be used there. And likewise, there are many such applications. I'm just mentioning two. Any other question? So, sir, how to optimize nanocellulose synthesis from tropical fruits? इसको ऐसे आंसर करना तो मुश्किल होगा. All I can say is that, and in fact, there are many papers. You know, your goal should be, let me put it this way, your goal should be, how do I extract cellulose in a more benign manner? एक बार आपको cellulose मिल गया ना, उसके बाद cellulose से cellulose nanofiber बनाना is not a big deal. But extracting cellulose in good form without using hazardous chemicals and without losing its functionality is much more important than anything else. वो first part बहुत critical है. People do not pay attention to that. उनको लगता है सीधे सीधे मिल गया, आपने कॉटन फाइबर लेके बना लिया, वो तो इजी बन ही जाएगा आपका. But starting from something like, as you mentioned, tropical fruit, starting from there till cellulose, it's a job. It's not easy because that's a pre-treatment process and a biofuel process. You understand that, right? Lignocellulosic feedstock, how do you break it down into cellulose, hemicellulose and lignin? That has to be optimized first. Once that is done well, उसके बाद का process तो straightforward है, चाय बनाने जैसा है, simple. No, there is no. So question is, are there any commercially available bio-based egg replacer? I don't think so. We are the ones who are doing this now. In fact, one of my students is now having a startup, and we are trying to work with ICMR, as I mentioned, Director General ICMR, to try and take this forward with government. If that happens, that will be good. Our target area is Gujarat, but we are also looking at pan India.
Okay.
Any other question? Any commercially ready to eat iron rich products available? Very soon, very soon. We are actually establishing our FSSAI factory. Once this FSSAI license factory will be ready, I think this process will begin very soon. And hopefully within a month or two, we should have these products ready. But we are not targeting market directly at this moment. We are going for clinical trials first. We want to prove certain things in a big way. And this human clinical trials results, when they are out, then we will go big way. We are still going a little slow on that because we are making some claims and those claims have to be validated. How
One
does
more
the
question.
structure of bio-based egg substitutes mimic the emulsifying and binding properties of eggs? No, they are not. No, our approach is different here. So Dr. Mishra, your question is valid, but not in this context. I'll give you the context. We are not looking at emulsifying property and binding property of these particular egg substitute. There are two different research that we have done. We have developed protein powders and we have made changes in that so that we can make those properties, functional properties, similar to eggs. That is there, that we have published also. But the egg replacer part that we are mentioning, it is only in terms of quality and quantity. Much more, in terms of quality, is much more useful in terms of essential amino acid profile, and quantity wise, it's double or triple compared to one egg. So that's what I was trying to say. Tea consumption with food is bad only with milk tea or black tea. What is the best way to take tea? Okay, it's a very good question. Doesn't matter whether you are taking with milk or not. Let me tell you the chemistry part, how it works. When we take food, food will have iron. When you take non-vegetarian, sorry, when you take vegetarian food, okay? So vegetarian food will have iron in wheat, some part will be in rice, some part will be in dal, right? And vegetables will also have micronutrients. When you consume it, they are all in Fe3 plus form. These are all ferric iron. Now ferric iron, when you consume it, and when you take tea, doesn't matter milk wala tea hai ya bina milk ka tea hai, tea is known for polyphenols, right? जैसे आप श्रद्धा कपूर वो भी बेचती है लिप्टन टी एंड ऑल दैट, this green tea or black tea, these tea will have polyphenols. These polyphenols have a chelating capacity. Chelate बोल लीजिए, chelate बोल लीजिए, whatever you want to say. So they bind these Fe3 molecules and put them in a very strong phosphate network. एक बार ये phosphate network में फंस गया, it's very difficult to get absorbed in our body, okay? And it is rejected by gut. It will never get to the intestine and get absorbed. It's just getting rejected right there. So it will never have opportunity and it is out from the system. So it doesn't matter whether you are taking with milk or without milk. अगर आपको चाय पीनी ही है तो अपने खाने से 3 घंटे का डिफरेंस बना के रखें, मिनिमम 2 घंटे का डिफरेंस बना के रखें.
Okay. I hope all the questions are covered from the participant side. Uh, we are able to understand very important topic today, like commercial pectin production, mango, pomegranate, pineapple biorefinery, biodegradable packaging. Sir, elaborate all these things very nicely. Thank you very much, sir, for giving informative, knowledgeable session to our participants. I hope all the participants will be explore knowledge in their research work as well as future work also. Thank you very much, Amit Arora, sir.